All right, 412, talking about trig, the survey of trig, they say. So, right triangles. So that's what trig applies to. Trig is all about solving right triangles. Right triangles have one right angle, obviously that's why they're called right, and then two acute angles. Okay. Relative to each side, they have an opposite and adjacent side, and I'll show you how to label those. All right. So find the length of the hypotenuse in each triangle, round to one decimal, then use the triangles to complete the table, which will be on my next slide. All right. The measure of each angle is the same in all three. Oh yeah, including this one up top. Okay, 63.4. All right. So let's write that 63.4 degrees. 63.4 degrees. We use this little symbol oftentimes. Greek letters are used, and it says it right here. I cut it out on accident. In trig, Greek letters are used often to represent angles. Okay, so this one is an alpha. It's a small a. There's also, we use beta or theta, like it says in that little yellow post-it note there on the side. Okay, so what we want to do to solve for these right triangles is just to use the Pythagorean theorem. So on each of these, we want to solve for the hypotenuse, which is my c value, and remember that a squared plus b squared equals c squared, which will come up more in this section. So what I want you to do, a and b are interchangeable. Remember, c is the most important one. I want you to actually solve these right triangles. So solve for c in both of these and check your work. All right, let's take a look here. I did 4 squared plus 8 squared equals c squared. Okay, 16 plus 64 is 80. And after I square root both sides, I got 8.9. Okay. Same idea here. 3 squared plus 6 squared equals c squared. 9 plus 36, which is 45. Square root both sides is about 6.7. Okay, so now we want to fill out the table. Let me go find that. All right, there we go. So it says the side opposite of our angle, the side adjacent to. So what I want to do is I'm going to label my sides. So my angle is in this upper corner here. The side opposite is straight across. That's the opposite. This is our hypotenuse, and this side, the leftover side, will be our adjacent. The same thing here. Start at our angle, draw an arrow straight across. That's your opposite. Hypotenuse is across from 90, and your leftover side is the adjacent. And that's kind of how I label the triangles. Okay. So first one, I want to do triangle A, which is the one on the left here. I want to say the leg of the hypotenuse, the length of the opposite side over the length of the hypotenuse. So I want to do opposite over hypotenuse. So the opposite side is 8. The hypotenuse was 8.9. And if I actually divide those two, I get about 0.90. All right, let's use the adjacent. Okay, look at your book. The adjacent side was 3. The hypotenuse was 6.7. 3 over 6.7 is about 0.45. And lastly, opposite over adjacent. So 8 divided by 3, which is where? 3. I'm looking at the wrong one. It should be 4. So I was looking at triangle B. This should be 4. 8 divided by 4 is 2. Let's keep going. Triangle B. The opposite side in triangle B is 6. Hypotenuse was 6.7. So 6 over 6.7. If I divide that, I get 0.9. The adjacent side is 3 over, see, this should be, holy buckets. This should be 8.9. I apologize. All right, so now we're going 3 over 6.7. And that's also 0.45. And lastly, I go opposite, which is 6, over adjacent, which is 3, and I get 2. Well, if you notice, what do you notice about the ratios in the table? What do I notice about all these decimals? The ratios are, look, 0.9, 0.45, and 2, the same. The same. Okay? So what are we doing today? Can you write the 6 trig ratios for an angle in a right triangle? And do you know how to find the measures of sides and angles in a right triangle? All right, trig functions. The ratios when we compare two sides of a right triangle. There's 3 basic ones that you've learned about previously. Those are sine, cosine, and tangent. Okay. Their abbreviations look right like this. There are also other trig functions. There's 3 additional ones, all right? 3 more. Okay, these 3, all right, are reciprocals of the 3 basics. Okay, so sine and cosecant go together. Every function has a cofunction. All right, that's how I think about how do I match these, sine and cosecant. Cosine, this is already a cofunction, goes with secant. Tangent goes with cotangent. Okay, and it's important to recognize and notice that it is the reciprocals of each other. So I have sine and cosecant. Well, if sine is 3 over 5, cosecant is 5 over 3. Reciprocal means flip the fraction. If cosine is 4 over 5, then the secant is 5 over 4, and tangent and cotangent, and so on. Okay? You know, I mean, you probably have heard of this or seen this before. All right? The book writes it in a different way. I like to write it like this. SOHCAHTOA. All right? The book chooses to write it like this. And while this second form, these mean the same thing. I choose this top way because I can see it. I can see the letters written as a ratio. O over H, A over H, O over A. There's no ratios in this second form. All right, so let's look at this one. It says opposite and adjacent refers to lengths of legs of triangles, not the hypotenuse. That's very important to recognize. Find the ratio, yada, yada, yada. All right, let's try one. A triangle has a hypotenuse of 50 centimeters, leg of 48. So let's draw ourselves a right triangle. There's a right angle. I know the hypotenuse is 50. Leg of 48 centimeters is opposite of our angle, so I'm going to draw an angle theta here. So then the opposite side is 48. Find the length of the remaining leg and use the 6 trig functions. All right, so I know that this side, we'll just call it A. All right, A. Okay, now, how did I know to put my angle down here? I didn't. I just chose to. I could have put it up top. Okay, that's not wrong, but your 48 would have been down here. All right, so that's the most important part is where the 48 goes, not where this theta goes, right? This little symbol here, this Greek letter. I could have, like I said, I could have put the Greek letter up here, okay? So we want to find the remaining leg, so I'm going to use the Pythagorean theorem. A squared plus 48 squared equals 50 squared. Right, so I got A squared plus 48 squared is 2304. 50 squared is 2500. Subtract it. A squared equals 196. Square root, A is 14. So this, all right, so let's label this. We knew already that 48 was the opposite. This is the hypotenuse, and that makes this the adjacent side. I want to find our 6 trig functions. So sine of theta, opposite over hypotenuse. Okay, opposite is 48. Hypotenuse is 50. That means the cosecant of theta is going to be 50 over 48. All right. We should reduce these. Divide both by 2. 24 over 25. Divide both by 2. 50. What's the next one? Cosine. Cosine of theta equals adjacent A over H. So 14 over 50. Divide both by 2, I get 7 over 25. Secant goes with cosine, so it's 50 over 14, which is 25 over 7. Lastly, I have, let's go green again. I have tangent of theta, O over A, opposite over adjacent, 48 over 14, which equals 24 over 7. Holy buckets, this is so much fun. Cotangent of theta would be 14 over 48 then, which is 7 over 24. So anytime they ask for the 6 trig functions, I just like to line them up like this. I know that sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. And that helps me a lot. All right. Number 4. Okay, use the lengths of the sides of the right triangle to find the following. Check the results using a calculator. All right, so here we go. Excuse me. So let's label our sides. First things first, O, H, and A. All right, the O, H, and A. If I want to find the tangent, I know that is O over A, so 2 over 4.3. So the book wants us to test to see, they're saying that, if the trig ratio, so 2 over 4.3, is going to be equal to whatever the tangent of 25 is. So let's check that out. So what I'm going to do is I'm going to pull up Desmos scientific calculator here. So I'm going to use Desmos, what was it? 2 divided by 4.3, that's 0.465, whatever. So let's also click, main, tangent, 5. They're basically the same. 4.66. Basically, or excuse me, 0.44. It's basically 0.47. Okay. So it's about the same thing here. Sine is opposite over hypotenuse, so 2 over 4.7. Try that. 2 divided by 4.7, enter. And then I'm going to do sine, what was the angle? 65. And look, they're not the same at all. I made a mistake here. I realized what I just did, okay? I did the sine of 25, but they're asking for the sine of 65. That's my fault. Where does the 65-degree angle come from? It should be right here. All 3 angles have to add up to 180. This is 25, that means this is 65, okay? This is actually a sine. 25 is that, so let's just see if it would make. Yeah, these would be the same. All right, my fault. I apologize for that. So find each value using the calculator. Okay, these are co-functions. So unfortunately for us, there is not a co-function here. Okay, there's no cosecant. I can't type cosecant into the calculator. So what I need to do is this is 1 over the sine of 82. This is 1 over the tangent of 19. And this is 1 over the cosine of 37. Okay? Remember, these are their reciprocal functions. They're co-functions. Okay, they're the reciprocal functions. Will we ever use the reciprocal functions to help us solve a triangle? Probably not. Okay, because we have our normal functions. All right, so I'm going to do this. Okay, go ahead and give it a shot yourself. Use your calculator. If you use the graphing calculator, you want to make sure your mode is in degrees. So I'll go to mode and make sure degrees is selected. Okay. For those of us that are not, I would use the Desmos scientific calculator on our school or on our Schoology page. So go ahead and try that. Here we go. Here should be our three values: 1.01, 2.9, and 1.25. 1.01, 2.9, and 1. Let's keep going. We're almost done. This is just a bunch of stuff talking about solving a right triangle here. If you want to solve a right triangle, that means find all missing sides and angles. So the book chose to use sine to find A, to find this side there. Okay. And then what I can do instead is just do the Pythagorean theorem to find the third side. I wouldn't use trig again. I would use the Pythagorean theorem. That's what we're going to talk about now. Okay. So trig functions can also be used to solve real world problems. Okay. A surveyor is standing 150 feet from a building. Okay. Finds an angle of elevation to the top of the building is 72.5 degrees. Find the height of the building, assuming the line distance is eye level of the surveyor is 6 feet off the ground. Note the figure is not drawn to scale, obviously. No kidding. So what they're asking us to do is to find this side here. Okay, so I'll call that x. All right. And what we want to do, so angle of elevation is very important to understand. Okay, look at this guy is standing here, he's looking up. Elevation means I'm elevating my head and looking up. There's angle of depression, which is this angle here. All right, but these two angles are the same anyway. So I always, and I don't like to use the word always, but I'll always put the angle down here no matter what. When solving a word problem. Anyway, let's do this. Let's try and find, let's use trig O, A, H. So I want to find O, then I want to find this opposite side, and I have my adjacent side. So that means I'm going to use, as people like to call it, TOA, or tangent. So tangent of our angle is 72.5, is equal to the opposite over the hypotenuse. Opposite is x, should be adjacent. Adjacent side is 150. Now I know to use tangent or TOA, okay? I know to use this because I have O and A. O is what I want. I want this side. A is something that I have. I don't know what this line, I don't know what the H is. I don't know what the line of sight is, so I can disregard the H and throw it out. So that automatically means I'm going to throw out sine and cosine, and then this is the one that's left over. All right, so let's solve for x. I like to think about this as being over 1, and then we can just cross multiply and say that x equals 150 times the tangent of 72.5. And that's exactly how I punch it in my calculator. 150 times the tangent 475.74. X is 475.74. We want the height of the building, and all we know is the height of this piece right here. So we have to account for how tall this man is. They're 6 feet. So 6, okay, you would get 481.7. Holy cow, this is a long video. Let's keep going though. All right. Then we talk about finding missing angles. To finding a missing angle, we use the inverse trig function. A right triangle has a side length. Find the measure of the smallest acute angle. So let's look here. I have the side lengths. Our longest side will always be our hypotenuse. And from there, I can just fill these in. Does it matter where I put the 16 and the 14.4? No. Find the length of the smallest acute angle, which is opposite of the shortest side. The shortest side is 6, so I'll use this as my angle. So this is opposite, hypotenuse, adjacent. So I can use my favorite trig function. I'm just going to use sine. Sine of theta equals 6 over 15.6. How do I find theta? Theta equals the sine inverse of 6 over 15.6. Okay, that comes from, if you're using your graphing calculator, you hit second sine. If I'm using Desmos, I just go over to functions, and I see sine inverse right here of 6 divided by 15.6. All right, should I keep going? I suppose. Solve each right triangle. How do you solve a right triangle? Okay, find the missing side lengths and the missing angle measures. You find everything. I think we're good. I think we've done enough of that. Okay. If I want to find this missing angle here, I would just subtract from 180. What do we learn today? The 6 trig functions and how to use them to find missing sides and angles.